Now, we're talking logs, and I want you to just appreciate that a log is an inverse of an exponent. Now, that sounds all sort of technical, so I'm going to try and slow it down and give you a few examples. So if I looked, for example, at 2 to the power of 3, every one of you at home are going to say, well, that's equal to 8. Easy peasy lemon squeezy. Okay, so we've got 2 to the 3 is equal to 8. But if I change it slightly and I said 2 to the x is equal to 8, what is the value of x? Suddenly we've got an exponential equation. And again, you know the answer, and we could say, well, x is equal to 3. What's the big deal, Mark? That's easy. But what I want you to understand is that logs are used to solve nasty exponential equations. Okay, I'll say that again. Logs are used to solve the nasty big daddy type questions. So when you've got something like this, so if you've got 2 to the power of x, this is not a nasty, a 16, everyone says, well, x is 4. But if I go and say 2 to the x is equal to 17, what is x? You're going to say to me, that's nasty. And I can't do that in my head. And in fact, this thing is irrational. The answer is going to carry on forever and ever and ever. And so we're going to understand in this little segment how to use a log to solve this kind of question. All right. So what I'm going to do is I'm going to go and I'm going to play with a couple of laws and play around. I just need to look at my notes so that I don't ramble and get too sidetracked. If I have got something like this, and I say the log of 8 to the base 2, and I say, what does that mean? This essentially is a very sort of similar question that's reworded. So if I've got 2 to the power of x is equal to 8, I'm saying, what must 2 be raised to give me 8? Okay, what must 2 be raised to give me 8? And then I'd say, well, x is 3. In the same way, a log says to me, what is the exponent of this thing over there, which is my base? So what is the exponent that the base must be raised to give me 8? So I'd go and I'd say, well, the log of 8 to the base 2 is 3. And if I have to choose another one, for example, let's go to the log of 100 to the base 10. Now, I want you at home to think about that. Think what I've done earlier on. I'm saying, what must this base be raised to give me that number? And I hope that you all appreciate, hang on, log 100, 10 squared is going to be 100. Because we go and say, well, 10 to the power of 2 is 100. The answer to a log, okay, is the exponent to which the base must be raised. Now, I want to show you something really cool. So those of you that have got this funky Casio, okay, this calculator is it, okay? I don't know if you know, Indiana, this is the Casio FX82ES Plus. If you say that at a party, chicks will think you're cool. The FX82ES Plus.
This one?
Yes.
That is amazing.
Okay, so now what I'm going to do is I'm going to go and put this on a calculator. So I put the log in, and I've got a log, and you should, I don't know if you can see that on the screen. Unfortunately, it's a bit small. So I've got a base and I've got a number. So what I can do is I can type in my base. I'll do the first one, base 2. Then I'm going to scroll to the right-hand side, and I can type in the number 8. Oops. This is a bit sensitive, the screen, just like a lady. Okay, so I've put the 8 in there. I've got the log of 8 to the base 2. Press equals, and my answer is 3. And similarly, if I go back over here, and I go and press this one over here, so I'm going to press the log button that enables me to put in any base and to put in the number. So I go and put in my base 10, scroll out, put in 100, press your answer. Bob's your auntie, the answer is 2, because we know that 10 squared is 100. So you can see this is easy, but if I take you to something really nasty, so let's just go to a new page quickly. So then your teacher says to you, all right, oopsie, let's get to my pen. I've got 2 to the power of x, and that is equal to 50. What is the power of x? It's very, very, very important to be able to write this into log form. So I'm saying, what must 2 be raised to give me 50? When we write it into log form, we are saying the log of 50 to the base 2. I'm saying, what must 2 be raised to give me 50? And I'll give you a bit of practice so that you can see how to write this. But now I can work that out. And I can press it on my calculator. Oops. So I'm going to press my log. I'm going to press my base is 2. My base is 2. Put in my 50. Bob's your auntie, 5.64, and so it carries on. Okay, so that is one of the greatest skills that we can use our logs for, is to solve a very nasty exponential. Now you're going to encounter this in finance, you're going to encounter this in log sections, anything that deals with powers. You now have a tool, you've got this calculator that can solve it. And so I just want to give you a little rule. So if you've got 2 to the power of 3 equals 8, and I want to write that into a log form, what I always say to my students is the base becomes the base. Now you're going to think, oh my word, it sounds like advice from my mom. You're saying nothing. The base becomes the base. This is my base. So when I go and do my log, there is my base. And so what I say is the base goes across to become the base. And so the log of 8 to the base 2 is equal to 3. And so it's a slightly different angle, all right, to doing some of these log things. But this is some theory. I need to do some of the log laws, and I know again that many of your teachers have taught you, but there might be some of you who are looking at the show for the first time thinking, oh my word, this is the best thing I've ever seen, and I'm going to learn a new section that I've never done before. So I'm going to go through 5 of the log laws, and then we're going to practice a few examples. And I think, Indiana, you're going to tell me when I've gone too long and the viewers are getting bored, and we're going to go to a break.
Well,
all right?
Mark, if I can actually jump in now, I think the viewers are actually really liking you. Can you imagine? And Dile wants to know, what if you haven't been given the base, but given the answer and the power? And then he says, eyes staring at the calculator,
Okay.
with a little smiley face.
Fantastic. You know, I can do that. Andile, if you're there, just have a look. I don't want to get too sidetracked based on my lesson plan, because we might go a bit ahead. But if you don't know what the base is, okay, I want to make it clear. You use logs when it's nasty and you need to get a calculator answer. So let's just write somewhere, okay, write on the coffee table at home, when you want a calculator answer, that's when you change something to log form. When you are not going to use a calculator and it works out quite nicely, that's when you go to exponential form. So you change from log to exponential form, and that's where you're going to solve. So what I would do here on Dile is I'd say, all right, the base becomes the base. If I'm changing from log to exponential form, this is my base. The base becomes the base. So I'd go and say, well, 8 is equal to x to the power of 3. I'm close to the answer. What I would do is I'd just take the cube root, oopsie, I take the cube root of both sides, take the cube root of both sides there, and so I end up getting x is equal to 2. So in actual fact, ideally, you can solve for any unknown, whether it's a base, whether it's the number, whether it's the exponent, but just rearranging and doing exponents. So I'll recap. Okay, listen carefully. Use a calculator when it's a nasty example, especially when you're getting decimals. When you're solving those nasty ends in the finance section of your paper. But if you're just solving for an unknown without a calculator, exponential form.
Fantastic, Mark. You know, he actually, Andile said, he wrote back and said, yes, logarithms, I've waited for this section for the past 2 years. I remember when I couldn't solve x in grade 10, I used logs, which at least earned a mark. Now it's time for the real thing. So I'm sure he's really excited.
This is the real deal, Andile. Okay, so I'm going to look at a couple of the laws. And again, this will be in any good textbook. You've all got good teachers, so your teachers will go through this with you anyway. But it's just important so that I get into my nasty questions. So one of the first laws is we say, if you've ever got the log of 1, irrespective of your base. So I'm putting a little a, we don't care what the base is. The log of 1 is always going to be 0. That's one of the building blocks of logs. We go to the second law, and the second law says to me that if you've got a number to the same base, it doesn't matter what your base is, it doesn't matter what that number is, that is always going to be equal to 1. So, for example, if I just illustrate here numerical, if I say the log of 5 to the base 5, I'd say that's 1. But just think about what a log is. A log says, what must this base be raised to give the number? Well, if you're getting to the same number, it has to be raised to 1. Makes sense, doesn't it? There's just a little proviso here that sometimes we forget to say. When you're dealing with the number, okay, the number must always be positive. So a must always be positive. Greater than 0, it must be positive for my actual number. Okay, so I'm talking about the number of a log, always positive. 3 more laws, okay, so hopefully they're not getting too bored, Indiana.
No, I'm sure they're not.
They gripped.
Yeah, no, the page is definitely pumping. Don't worry, they're chatting.
Okay, okay, now we've got the sum. Excuse the handwriting, but I'm a man and I'm not going to apologize for that. I'm adding 2 logs together. I've got the log of x, yes, that's an x in case you're wondering, to the base a, plus the log of y to the base a. And your teachers would have said to you, when you add two logs, make sure the bases are the same. If the bases are the same, then you write a single log to that base and you multiply the numbers. All of these little laws, I'm going to illustrate through examples just now, numerical examples. So if it looks very hypothetical and abstract, don't panic. I'm going to go through with an example. Adding two logs, you multiply the numbers. You never multiply logs, that just doesn't happen in mathematics. You multiply the numbers, the x and the y, and you write log to a single base. Second to last law that I'm doing, okay? And what I'm going to do here is I'm going to say, well, actually, what happens if we subtract two logs? So if we are subtracting two logs, what I do then is, again, I write a single log to my base, but I divide. So the term that is being subtracted, it becomes the denominator. And sometimes we call this the quotient law, that one there we call the product law. So subtracting two logs with the same base. Got to be the same base, you divide the numbers. And then finally, the last one, which we're going to call the power law. So at school, you've learned about the product law, you've learned about the quotient law, and you're going to learn about the power law. So let's just see. So if you've got the log, with the base a, of x to the power of n, we can quite easily rewrite that as n multiplied by the log of x to the base a. And again, it probably isn't making sense to all of you at home if you haven't done this kind of stuff yet. But it will make sense when we look at an example. So let me just illustrate. If you've got the log of 5 to the power of 2 base 3, I'm allowed to write that as 3. I'm sorry, excuse me. It's got to be 2. I'm allowed to make mistakes, aren't I? Okay, so I take the 2 to the front, 2 log, and that is 5 base 3. I take the power to the front. Now, let me show you an example of how I can use that. If you've got the log of 25 to the base 5, and I say, please go and work that out without a calculator. Well, if you have absolutely no idea, and your teacher says, don't use a calculator, well, use a calculator. But you only use the calculator to see the answer so you can try and understand the mathematics behind it. So if I just go and press the log, and I press base 5, and I go and press 25, remember what we're saying is what must 5 be raised to give me 25? Press equals, and the answer is 2, and you all knew that the answer was 2. Okay, so now, if I just use the log laws, I could say that 25 is the same as 5 squared. Now look at the little clever tricks, because now I'm using all of the log laws from above. I've written just 25 as 5 squared. I can then take the 2 to the front, because that's the power law, so it becomes 2 log of 5 base 5. And we learned earlier on, hey, power law, that goes to the front. Log of a number to its base, that is just 1. And so my answer is 2. And so what we're doing is we're starting to use the log laws using wonderful algebra to help us go and solve. How am I doing for time?
We're doing good. About a minute. 2 minutes.
Let me do
Carry
one.
on. I'll stop you. Okay, Mark.
Good.
I'll say stop and then.
Fantastic.
Okay.
Stop. You're a speed cop. Okay. I'm going to go and do an example or two. I've jotted down some examples just to help us understand and concretize those laws. So let's put the same thing over here. Minus 2 log 9 base 9 plus the log of 1 base 2. So I'm going to look at each piece individually. You've just seen that I can write that as 2. That's perfect. Here where I've got the log of 9 base 9, you know that that is just 1. When you've got the same number, but the number at the front is negative 2, so I'm going to get negative 2. When you've got the log of 1, irrespective of that base, this thing is always going to be 0. The log of 1 is 0. And so what you're doing is you're adding 0. Okay? And so your answer is 0. I've said 2 minus 2 is 0, plus is 0. And so I'm going to get 0.
Funi wants to know, let's have a look. She says, he or she, I'm not quite sure, says, what about when you've got different bases in a log? How do you solve it then, Mark?
Fantastic, Funi. Let me help you. Okay, what we do, I've written something up on the screen which has different bases. You need to understand that the log laws will only ever happen and allow you to put things together when you have the same bases. So I've got different bases. So what do? Panic. or do what we know what we can do?
Panic.
No, don't panic. Don't panic, just take one step at a time. So you say to yourself, those bases are different, they can't combine, so that is when you deal with each part individually. So take it one step at a time, and I'll almost do this log of 1 over 7 to the base 7 independently of the right-hand side. Now for some of you that have been paying special attention, we say, what must 7 be raised to give me 1 over 7? Many of you can do that by inspection. 7 to the negative 1 is 1 over 7, so the answer is negative 1. But look how I use the log laws. What I'm always trying to do is I'm trying to get the base and the number to look the same. And you might say, but Mark, that's not mathematical. I'm not finished. 1 over 7 can be written as 7 to the negative 1. And then using the power law, I bring that power, whoa, what happened there? Let's bring it back. I take that power to the front, and so I'm going to get negative 1 log of 7 to the base 7, and we know the log of a number to its base is 1, and so this component is negative 1. Okay, so for me, I'm dealing with little pieces at a time, and that's how you should tackle any nasty mathematics, little bite-sized chunks. Now this next one is a bit nasty. If I'm not sure, and the question says without a calculator, I'll press on my calculator just so that I know. I don't want to get it wrong. So I'm going to press your log, the base is 27, I'm going to scroll up, I'm going to put 81, okay, press equals 4 over 3. Okay, I know the answer is 4 over 3. I don't know why yet. And I'm not going to cheat. I'm going to try to get there independently. Now, if you're not allowed to use a calculator, earlier on I gave you a massive hint, Funi. I said to you, when you're doing logs, if it's a nasty answer, calculator. If they say without a calculator, you convert to exponential form. So look what I'm going to do here on the side. I'm going to say the log of 81 to the base 27 is equal to x. I'm saying let this answer be x. I'm saying what must 27 be raised to give me 81? Let the base become the base. So I end up saying, well, 81 is 27 to the x. Remember that little law to convert from log to exponential or exponential to log. I just say let the base become the base. And now you can use your laws of exponents. 81 is 3 to the power 4, and I must just remind you, you have to know your exponent laws, okay? Listen to the grade 11 show because you need to know your exponent laws to be able to do the grade 12 logs. 27 is 3 cubed, so it'll be 3 to the 3x, and hopefully you remember you can drop the base, okay, when you've got the same bases, and so you end up getting 4 is equal to 3 to the x is equal to 4/3. So I get to the same answer as my calculator. And so now what I can do is I could go and say, well, this component, now I haven't set it out nicely, but I think you can see what I'm doing, is 4/3. And so because I was adding these two answers, minus 1 plus 4/3, that is going to give me 1/3. Okay, so hopefully, Funi, we've answered your question. Even though you might get something a little bit more complicated, just remember that if the bases are different, you raise such a wonderful question. We can't use the log laws where we combine things, but we can still do the log laws when we take each piece individually and work out on its own. And so when in doubt, take a log and convert it to exponential form so that you can solve. I think I've got enough time to maybe do one more of these and then 1 or 2 log equations. So I've covered the section thoroughly, or as well as you need to be able to do some more questions. Okay, so I'm just going to throw out something that's got some nasty surds. Why not? And remember at home, try and see if you can do this before I give you the answer, so you can see if you've totally understood what's going on. Now, one thing that I didn't mention earlier on, and again, I'm assuming that you've done a little bit of logs at school, so I'm not just starting from scratch, I'm going very quickly. There is no base, and there is no base, and there is no base. Now, we don't say that a log doesn't have a base. What we do is we say if no base is written, then we take it as if that base is 10. So you could choose to write the number 10 if you really wanted to, and your teacher might initially always write the number 10. But you don't have to write it. It's automatically there. It's like when you've got x, it's x to the power of 1. Sometimes something's hidden and you don't have to write it. And with logs, you don't have to write that 10. So they all have the same base. Now I want to merge them. So Funi, this is slightly different. This is the one where all the bases are the same and I can put them together. So we said earlier, if you add 2 logs, what you do, you write the word log, you keep the base. I don't have to write 10, but now I'm going to multiply these 2 together. So I'm going to be multiplying root 8 times 2 root 6. But I was subtracting this log. And so when you subtract the log, you're actually dividing the number. Remember, you never divide a log. Never ever. Look at that law very carefully. You divide the number. So underneath, I'm writing the square root of 3. And it's at this point now that you just use your law of surds and you're going to go and simplify. And look, we're not going to go to a decimal place. I just want to simplify as far as I can. Let's look at some surd stuff. So again, this would be grade 11. 8 is 2 root 2 times 2, and then root 6 I can write as root 2 times root 3. My apologies. So it's 2 root 2 times root 3, and that is all over root 3. And so I notice, because I'm going to use my normal algebra, I can cancel. A root 3 will go with a root 3. And so I'm going to go and multiply. I'm just going to multiply 2 times 2 is going to give me 4, and root 2 times a root 2 is just going to give me 2, and so that is log of 8. But it's not really the emphasis that I want to make here on surds. The emphasis is on how do I add logs when they do have the base, or subtract logs. And remember, adding, multiply the numbers. Subtracting, divide the numbers. But it's a single log, keep a single log. Now I'm going to do 2 examples on the log equations. Okay, so we're nearing the end of my teaching section. Breathe a sigh of relief, okay, Indiana. Let's go.
You're doing well, Mark.
Log equations. Now, obviously, with an equation, we're solving for x. So we're saying, please find the value of x. You're going to see some kind of equation. And the very first thing that I show you is really going to be the premise upon which everything is based. So if I have log of 3x to the base a equals the log of 10 to the base a, I've just thrown out something random. I hope you all understand that if I've got a log equals to a log and the bases are the same, and that's critical. You should be writing at home, hey, the bases must be the same. So it's the same base, and you have a single log equals to a single log. And you say to me, oh, but Mark, it's so obvious. If you take away the logs, if they're performing the same function, log 3x to the base a equals log 10 to the base a, surely 3x is equal to 10. And then I can just go and solve something. And so that is what I want to do with any log equation. It looks very simple, but I'm going to use my log laws to kind of rejumble everything, put everything together, and try to get a log equals a log. And if those logs have the same basis, you can just drop the logs, throw away the logs, and equate what's left over and solve. Let me show you. So I've written up something over here. If I've got the log of x plus the log of x minus 2, and I'm saying that that is equal to the log of 15. You cannot drop logs yet. Look carefully. I want a single log on the one side. That's 2 different logs. So I want a single log equals a single log with the same base. And if I had to say to you what base, hopefully you all said, 10. Base is 10. So I'm going to merge my logs. And so that log and that log together, adding logs, you keep a single log and you multiply the numbers. So there. And that is equal to the log of 15. And it is at this point that I can say log equals log, drop the logs. Throw away the logs, only because it's a log, single log, same base. And hopefully saying, Mark, quadratics. And now we're bringing in grade 10 stuff. So we're going to go and solve the quadratics. So I'm just going to go x squared minus 2x minus 15 equals 0. Let's just see if I can factorize. X. I know I'm working very, very quickly. Indiana, there's a repeat of the show at some stage, isn't there?
Yes, there is. I will be letting learners know when that is. And we're also hoping to, depending on the bumps and things, get it up onto YouTube within the next week or so. I will be letting learners know, Mindsetters, on the Facebook page and on Twitter as soon as these lessons are available on our YouTube channel. Yeah.
Okay.
And everyone's loving your show, Mark. Can I quickly give you a little bit of? Sapanda said he's learning new stuff. Atlin says great show. He thinks you're awesome. And Rosina says, Mark, you're amazing.
Rosina, you're making me blush. Okay.
Yeah.
Now, Rosina, come on, let's just see if you're really following the show.
Sorry, it's not Rosina, it's Rory Sang.
Royce, is that a boy?
No, it's a girl, and
Okay.
she's very pretty. Rory Sang Vanilla.
Okay, thank you.
Yeah, Rory
Rory
Sang.
Sang, just have a look here. I solved this equation. Okay, so I've gone all the way down to the end, and I get to my answers for x. But there's a problem. Now, don't look and see if I've made a mistake. I hope I haven't made a mistake. That's not the idea. But there is something that you should always remember at the end of any log equation. You see, you're solving for the value that will go and balance this. And at one stage when I was giving the laws, I said to you the number. This here is the number. The number must always be positive. If the number is not positive, then I have to reject my answer for x. So let's go to the end over here, and I've got an answer 5. So if I put 5 in there, log of 5, that's positive. 5 minus 2 is 3. That works out. That's good. If I go down to the bottom, x is equal to minus 3. Log of minus, there's a problem. And it just has to fail the test at one stage. And so what I have there is no solution. So you can either say reject this, you can say not applicable, you can cross it out. Anything to show the examiner that you understand that that answer is invalid and so you can't accept it. Remember, when you're dealing with log equations and you solve for x, always, always, always check. You need to check to see if that answer makes sense. Okay, one last one. Okay, before my producer moans, I'm going to do the last one and let's see if you're champions at solving log equations. There are so many things that I can do, but hopefully in the few that I have chosen, we've been able to practice the basic laws, and then we've seen how they apply, so you'll be a champion in no time at all.
No, everyone's saying so. Kaklejo says, well, I'm truly enjoying the show. Now I have the guts to enter the exam room. So Mark, there you go. Hey, job well done for the day.
I said to you, best day of my life.
Hey.
There we go. Okay, I'm going to solve this. This we can solve in one of two different ways. And so I'm probably going to do both ways. Let me put my piece of paper down. When we look at this, I've been saying to you, you want a single log equals a single log. But I can actually do this by using some of my knowledge of the exponent and log laws. You see, we're saying what must 3 be raised to give me that 2? And so I can change, okay, from log to exponential form. Remember, if you've got the log of x to the base a, and that is equal to p, for example, then the base becomes the base, and so I'd be able to say, well, x is a to the p. And I'm just using that as a little law. So the base becomes the base. 3 just becomes that base, and so I can go and say 2x minus 4 is equal to 3 squared. And it's actually given me a nice, simple little step. 3 squared is 9. So I've got 2x minus 4 is equal to 9. 2x is equal to 13. And so x would be 13, 13 over 2. I double check, okay, 13 over 2. I know that that's 6.5. 2 times 6 is 12 already. It's going to work. It makes it positive.